Hi, this is the first video lecture for our unit on solutions. We're going to start with the basics of solutions, which starts you off with 3 vocab terms that will be used quite often. The first being solute. That is the term for the substance that is being dissolved. Usually that is a solid, but it doesn't always have to be a solid. If we're making a pitcher of Kool-Aid, our solute will be the Kool-Aid powder packet, in addition to probably some sugar. The second term is solvent. That is the substance doing the dissolving. Typically, that is going to be water. And then a solution is the mixture of a substance uniformly distributed throughout another substance. Meaning, if I try to dissolve a Kool-Aid powder packet into a pitcher of water and take a sample from anywhere in the pitcher, it should taste exactly the same because the Kool-Aid powder is distributed throughout the pitcher evenly, making every sample taste the same. So we're going to go through some practice. I'm going to give you a solution, and I want you to think about what is the solute, what is the solvent that would make that solution. So the first one is chocolate milk. You can pause the video if you'd like. Figure out the solute and the solvent. The solute should be either chocolate syrup or whatever chocolate powder. And the solvent, the thing that we would dissolve the syrup or the powder in, would be milk. The next one is carbonated water. So what do you think the solute and the solvent are for that? This one is tricky because the solute is not a solid. The solute is actually a gas. We're dissolving carbon dioxide gas into water to make carbonated water. The next one is coffee, black coffee, not that Starbucks stuff. The solute would be the coffee beans and the chemicals inside of the coffee beans. And the solvent, again, would be water. Now, when we think about how much solute is in a given amount of solvent, that is called a concentration. So for instance, if I have a cup of coffee and I put 2 sugar cubes into my cup of coffee, and my friend is also having a cup of coffee, but they put 4 sugar cubes into their coffee, which person will have the more concentrated coffee? In this case, right, the sugar is the solvent, the solute. The coffee is the solvent. My friend who puts more solute into the same amount of solvent will have the more concentrated coffee. Now what happens if someone stirs in more sugar than they would like in their cup of coffee? How could they make it less sweet? The answer is to add liquid or add solvent. If you can increase the volume of the solution by adding solvent, then you will have less sugar per volume of solvent, making the concentration go down so that the coffee will taste less sweet. So if you can remember that concentration is the amount of solute per solvent, if I have way too much solute in the amount of solvent I have, I can increase the amount of solvent to make it less concentrated. Another option, if we want to make a solution less concentrated, besides adding solvent, would be to lessen the amount of solute that I put into the solution. However, that's pretty difficult to do once the solution is already made. Like, how am I going to take sugar out of my coffee? So typically if we want to make something less concentrated, which you'll learn in another video that's called dilution, we would rather add solvent. It's easier. If we want to make a solution more concentrated, we can add more solute. So I could add more sugar cubes. Or I could lessen the amount of solvent I have. However, again, that's difficult to do once the solution is already made. How could I remove coffee without also removing sugar? Difficult to do. We can measure the concentration of a solution using something called molarity. Molarity is defined as the number of moles of solute per liter of solution. So the equation is molarity, which is capital M. That's what you see on all my bottles of solutions that we use in labs. That is equal to moles of solute, which we represent with an N, divided by liters of solution, which you sometimes will see as either a capital V or a capital L, depending on the person writing the equation. The unit for molarity is molar, which is abbreviated with a capital M. A couple things to remember when you are doing a molarity calculation. N is moles of solute, which means I could give you grams of solute and ask you to convert it into moles first, which you should know how to do. That's compound stoich. All you need to do is use the molar mass to help you get it into moles. Also, keep in mind what I'm asking for. So in a problem, if I'm asking you to solve for N, make sure you're aware of whether I'm asking you to give me moles as your final answer or to convert it into grams. Typically, it doesn't make sense for us to have an answer in moles because, again, our balances don't measure in moles, they measure in grams. So I'll typically ask for grams, although I could also ask for moles. The other thing to remember is that your volume needs to be in liters. That is crucial. That's the number one mistake students make, is they do not put their volume into liters. We typically don't measure solvents in liters or solutions in liters, any volume in liters really. We tend to use milliliters. So if I were to give you milliliters of solution, you have to convert that into liters first. And hopefully you remember how to use the metric stairs to convert that. If you don't, I have a video on that. Maybe go refresh your memory. So for our first example problem, which is in your practice packet for Unit 6, so you can do it along with me, the problem says that you create 500 milliliters of sodium hydroxide solution. Using 1.500 moles of sodium hydroxide, what is the molarity of this solution? So I'm color coordinating everything so that you can see exactly where these numbers are coming from, where they're going in the equation, etc., etc. So I highlighted the two variables that are given to us, so the 500 milliliters and the 1.500 moles, and then I also highlighted the thing that you're being asked about. And this is your equation, and then I match the colors to the variables that they go in for. So 500 milliliters is the volume, 1.500 moles is N, and I'm solving for the molarity. Now the first thing we need to do, your volume, remember, needs to be in liters. So we need to convert milliliters into liters first by moving the decimal 3 spaces to the left. So 500 milliliters would turn into 0.500 liters, maintaining 3 sig figs. So that's why it's 0.500 liters. Once we've done that, we have moles and moles, so we can just plug that straight in for N. We can plug the 0.500 liters in for V, and we can divide those to get our molarity, which would be 3.00 molar NaOH. For sig figs, we are going to be using sig fig rules, which means when we're dividing, we're looking at total sig figs, and we're rounding our answer to the total number of sig figs as the starting number with the less amount. So 1.500 has 4 sig figs, 0.500 has 3, 3 is less than 4, so I'm going to round my answer to 3 total. And that's my answer. For the second example problem, let's say that I ask you to make me 250 milliliters of a 0.1 molar silver nitrate solution. How many grams of silver nitrate do you need to measure out? This is a pretty typical thing that I would ask of an assistant. So if you're thinking about being an assistant to me next year, it's a calculation to know. So since we are solving for, or we're being asked to solve for grams, grams is not in the molarity equation, but moles is. And we know that we can convert moles to grams. So I rearranged the molarity equation to set it equal to N. So I just multiplied both sides by V. That's all I did. So N equals M times V. We are given the molarity. I highlighted it in pink. We were given the volume. I highlighted that in green. And then we're asked for moles, which will then convert to grams. The first thing we need to do is we need to convert milliliters into liters. So 250 milliliters with the decimal moving 3 times to the left would give us 0.25, and that is maintaining the 2 sig figs that we started with. Right? This has 2 sig figs. We're going to maintain 2 sig figs here. You can plug that into the equation. So the 0.1 molar times the 0.25 liters would give us an N value of 0.025 moles of AgNO3. But that's not what I asked for. I asked for grams, which means I just need to do a very simple compound stoich problem, starting with the 0.025 moles of AgNO3, going down with moles of AgNO3, and up with grams of AgNO3. And when you find the molar mass, it should come out to 170. So 0.025 times 170 should get you 4.25 grams of AgNO3. And that'd be my final answer. For the third example problem, we have a 0.125 molar sodium nitrate solution containing 3.45 grams of solute. We're asked to find the volume of the solution. I rearranged the molarity equation again to set it equal to V, now that we're being asked for the volume. You wouldn't have to rearrange the equation. You could just put X in for V of the original molarity equation, and you get the same answer either way. But I like to rearrange it. So I multiplied both sides by V to get V out of the numerator or the denominator, and then divided by M to get V by itself. We are given the molarity straight up, but we are not given the moles straight up. We're given grams. So we would need to do compound stoich to convert 3.45 grams of sodium nitrate into moles, which looks like this. You start with the 3.45 grams in the upper left-hand box. We bring grams of NaNO3 diagonal down, figure out how many grams are in 1 mole of NaNO3, which is just the molar mass, should come out to be 85. When you do 3.45 divided by 85, you get 0.0406 moles of NaNO3, which we can then plug into the equation. We can divide that by 0.125 molar to get a volume of 0.325 liters of this NaNO3 solution. That is it for molarity. You do have a practice sheet to continue practicing molarity equations. This is kind of crucial for the rest of the unit, so please make sure that you get these problems down and you're able to solve these. All right, see you next time.